A switch performs forwarding and filtering based on the self-learned switch table. Filtering refers to the function that decides whether a frame should be forwarded or it should be dropped. Forwarding is the function that decides the interface that the frame should be sent out and places the frame on that output port. Using these functions, when a frame is received at the switch, the learning happens by recording the incoming link with the source MAC at the switch table. Then, the MAC destination address is checked, and if the MAC address is on the segment from which the frame is arrived, the frame will be dropped. Otherwise, it will be forwarded. Forwarding will either be directed on an interface indicated by an entry in the switch table, or if there is no entry available for that destination MAC address yet, forwarding will happen by flooding on all interfaces except the arriving interface. For example, if in the figure, a frame with source A and destination A' arrives at the switch when switch does not have an entry, the entry for source MAC A with incoming link 1 will be recorded on the table. Then, since the MAC address for A' is not available in the switch table, the switch will flood the frame on all of its interfaces except for port 1, since that is the port the packet came from. Now, if a frame is sent from A' towards A second entry for MAC address A' with the incoming interface number 4 is added to the switch table. Then, the MAC address A is checked up on the switch table, and since there is an entry for A, the frame will be forwarded on interface 1 based on this entry. One of the benefits of self-learning is that switches can be interconnected to build larger switching domains without any configuration requirements. For example, we can expand the layer 2 network from only including switch S1 and its hosts in the figure to a domain with 4 different switches in a hierarchical way, connecting more hosts in the same LAN. This could be done without any configuration, expanding on the plug-and-play properties offered through self-learning. The question is, how do we send from a host connected to one switch to a host connected to another switch? For example, from host A connected to switch S1 to host G connected to switch S3 with switch S4 in between. Sending from A to G in that network will be a process of self-learning repeated on S1, S4, and S3. This property could, for example, be used to form the LAN for a local network of an institution. This involves putting all of your users within the same subnet and connecting them using a hierarchy of switches. Is that a good decision? Or would you recommend using routers and designing our network in layer 3, using multiple subnets and routers? Think about it, and we will come back to it a little bit later. Even though switches and routers are fundamentally different and operate at different layers of the Internet Protocol stack, they are often compared in their functionalities because administrators come across the decision to design based on one or another. Switches and routers are both store and forward devices. However, routers work on datagrams on network layer or layer 3. This involves examining network layer headers. Switches are link layer devices which store and forward frames at the link layer. Therefore, they examine frame structure. Both switches and routers also have forwarding tables. However, routers' forwarding tables are decided based on IP addresses and are computed using routing algorithms and protocols. On the other hand, switches learn forwarding tables based on flooding, self-learning, and MAC addresses. each of these properties, and using them in designing a network might be desirable or not. This depends on the use case.